All right, number 8 is a pretty tricky problem if I remember correctly. I'm looking at the sheet here, and that's what's called an unknown integral, which means we're going to have to do integration by parts a couple of times. And so what we want to remember is that this guy equals, that's a bad equal sign. This guy equals u times v minus the integral of v du. Okay, that's what we need to remember because we're going to look for an integral that has this exact same shape somewhere over here. And on this guy, it doesn't really matter too much how you do it, but I'm going to go ahead and let u equal e to the 8th x. Why am I lagging here? So my dv then will be sine x. And this actually is going to work out pretty good because it'll be easier to work with, I think. Du would be 8e 8x, and v would be the derivative of what will give you sine, and that's going to be negative cosine. So when I follow my pattern, which is u times v and minus the integral of v du, I get this. And I'm gonna start way over here so that we've got plenty of room. We get this guy equals negative e to the 8x, negative 8e to the 8x cosine x minus the integral of negative 8e to the 8x cosine x dx. So I forgot my dx right here on the du part. Okay. Clean this up one step, and you'll notice that I have negative 8 as the inside constant, so he can actually come out front. Which now makes my integration almost identical to what we did just a minute ago. So I'm going to use blue all over again. And when I integrate this, I'm going to let u equal e to the 8x. And I do that because whatever I pick for you to start, I have to have with you for the long haul. So this is going to be 8e to the 8x. And dv this time won't be the sine function because I don't have him in this particular part of the problem, but I do have the cosine of x. And the derivative of the sine is cosine. So here's my setup for this guy. All right. And again, we're going to go with u times v minus v du. Okay. And the problem is going to get a little bit more complicated. So here we go. It looks like this. The integral of e 8x sine x dx equals negative 8e to the 8x cosine x minus now the integral. Let's see here. 8 times that whole integral. Okay, so I'm going to be plus 8 times now this whole integral, which is going to be u times v minus the integral of v du okay, and it looks like this. So I'm going to simplify this up and clean this up just a little bit, not very much, not a whole lot actually, but I do want to simplify this down because I can bring the 8 from here in front. And when I do that, notice that I want to have e 8x sine x, and here I've got e 8x sine x. So watch what this does. This is going to give us then this guy. Plus and distribute your 8, so that's going to be 8 e 8x sine x. And I'll move the 8 in front and multiply by 8, so minus 64 times the integral of e 8x sine x dx. And that equals this guy. All right. And since it equals that guy, what I can do is I can add 64 integrals of e8x sine x dx to both sides. And so what that gets me for my final answer then is something that looks like this. 65 times the integral of e8x sine x dx. And if that's what I have on the left, I can divide on the left by 65. I can divide what I've got on the right by 65, okay? And since I'm running out of space over my head, I will actually end up with this, that the integral of e to the 8x sine x dx is equal to this long old guy right here. Yeah, over 65 plus c. Okay, that's really, really long. It's really long, but that's what it is. And so when you're working those unknown integral problems, you gotta just be patient. The answer is going to get to you, but you've got to wade through a lot of algebra to get there. And if you look at this, the calculus part actually isn't the hard part. A lot of the hard part's the algebra. Okay, so there you go, an unknown integral.